Hello students, in this video we are going to discuss the analysis of the products from Catha edulis and Lophophora williamsi. The first drug plant which we are going to discuss is the Catha edulis, which is commonly called as Khat or Khat. A number of plants are known to contain drugs which are subject to control. Out of these, very less common items that a forensic scientist might encounter are included products of Catha edulis, which have different names on the streets as Khat, Cat, Khat, Jave, and Mulka. And the second plant is the peyote cactus, Lophophora williamsi. The khat or the khat is a flowering plant native to the horns of Africa and the Arabian Peninsula. Khat is a slow growing shrub or the tree that typically attains a height of 1 to 5 meters. However, it can reach a height up to 10 meters in equatorial areas. It has the evergreen leaves which are 5 to 10 centimeter long and 1 to 4 centimeter broad. The shrub's flowers are produced on the short axillary cymes that are 4 to 8 centimeters. Each flower of the plant is a small with 5 white petals. The samara fruit is an oblong 3-valved capsule which contains 1 to 3 seeds. The khat contains stimulants similar to the amphetamines, and it also contains dozens of non-cyclic nitrogen-containing compounds, alkaloids, as well as tannins, flavonoids, glycosides, and other compounds. Of these chemical constituents, the phenylalkyl amines, which bear close structural resemblance to the neurotransmitter dopamine, and norepinephrine are of greatest importance to the stimulant activity of the khat. The different phenylalkylamines which are present in the khat plant includes cathinone, cathine, norephedrine, murocathine, pseudomurocathine, and murocathine. These alkaloids are nearly 1% of the dry weight of the khat. These are the structures of different phenylalkyl amines present in the khat plant. The first one is cathinone, the second is cathine, norephedrine, murocathinone, pseudomurocathine, and murocathine. The identification and quantification of the Khat samples can be achieved in the forensic labs. The basic forensic science principle should be adhered to when carrying out the analysis of a Khat concentration. Prior to any chemical investigations, a full physical description of the material should be made and appropriate samples removed for subsequent analytical work. Wrapping materials should be carefully preserved since it may be possible to compare the stria on such packaging in attempts to relate various samples to each other. Once a suitable sample is obtained and described, the next stage is to analyze the material for the presence of cathinone and cathine. In addition to these drugs, other structurally similar compounds found in Catha edulis plants include norephedrine. It is well accepted that cathinone is converted into this compound by the process of enzymatic reduction. Further, the oxidation products 1-phenyl 2,1,2-propanedione and cathinone dimer may also be identified. The terms of identification of the material as Khat from Catha edulis it is necessary to demonstrate the presence of cathinone since this is not found in other members of this genus. The typical drug identification based on the chemical analysis depend on the presumptive test followed by chromatographic separation, and in general the material is extracted and the drug present are determined by using TLC followed by either HPLC or GCMS. In order for chromatographic investigations to be carried out, a representative extract must be obtained which is suitable for the analysis of the drug. A number of different methods have been employed for the extraction of the drug components. All these are based on the conversion of the drug to their water-soluble salt form by trituration of the dried plant material in dilute acid, basification of the extract, back extraction of the drug-free bases into an organic solvent which is immiscible with water, drying of the solvent, concentration of the extracts, and then finally analysis of the drug components. A comparative simple TLC system can be used for the analysis of these drugs involving separation on the silica gel using mobile phase which causes ion suppression and visualizing the chromatogram with neon hydrine. The chromatogram is prepared and developed and visualized by following the same principle as those used for the other classes of the drugs. While cathinone is reported to separate from other alkaloids, nor pseudoephedrine and norepinephrine do not separate in such a system, and thus further confirmation of the drug identity is required. And these can be identified by HPLC or by GCMS. The HPLC can be used to identify the drugs present in these controlled substances with resolution of cathinone, non-pseudoephedrine, and non-ephedrine being achieved on the silica gel with a mobile phase which consists of a mixture of 1,2-dichloroethane, methanol, acetic acid, diethylamine, and water. And once the chromatogram is developed, it can be visualized in UV at 257 nanometer. And this method has also been used to quantify the drug components present in these samples. The GCMS analysis of the alkaloids from the Khat is another approach to identify the drug. The two such methods have been described recently. One of these involves components analysis of the underivatized alkaloids on a 30 mHp5 instrument. The retention time of cathinone and cathine were 18 and 19.5 minutes respectively. If the sample shows same retention time as that of the standard, then the plant material can be considered as the Catha idis plant. The second products which are obtained from the plant Lophophora williamsi and the potent psychoactive compound present in this plant is called mescaline. This Lophophora williamsi was an important hallucinogen plant to the ancient Aztecs, and even today it is used by the Native American church as well as the being subject to abuse in other parts of the world. It is a small button-shaped cactus known as the peyote, which grows in Mexico and the southwestern United States of America. This cactus rarely grows more than an inch above the ground, with the remainder of the plant being formed by a long underground root. Such cacti can take 5 to 15 years to mature. The active compound present in Lophophora williamsi is mescaline, that is 3,4,5 trimethoxyphenethylamine, and it is a potent hallucinogen, and this compound is also called as peyote. In order to determine that a controlled substance is present, it is frequently necessary to carry out a full forensic analysis of such samples, which includes full physical description, sampling, subsequent chemical analysis involving presumptive tests, TLC, and confirmatory techniques. Where simple single package items are to be analyzed, the entire production in its wrapping should be described and the drug material then removed from the packaging. It should be next weighed and where possible a full physical description of the drug sample itself should be recorded. For a whole plant specimens, the materials should be dried to a constant weight and then cut into two equal pieces, one for analysis and one for court going purposes. The material for the analysis, once dried, should be homogenized, and if quantitative analysis are to be performed, the material should then be dried at 110 degrees Celsius to a constant weight prior to the analysis. Where a single powdered atom is encountered, it should be thoroughly homogenized and then subjected to the usual analytical analysis. And when the multiple packages have been seized, the following sampling protocol may be adopted. The material should be divided into groups of indistinguishable materials. Each group should then be counted. For a group sizes of less than 10, all of the atoms should be analyzed. For a groups between 10 and 100, 10 atoms should be selected at random and analyzed. For the groups of more than hundreds, the square root of the number should be analyzed. After material selection, the analysis can then be processed as TLC analysis, GCMS analysis, or HPLC analysis. The presumptive test for mescaline. There are a number of difficulties are associated with the color test on fresh and dried plant material, in addition to those associated with analyzing a primary amine such as mescaline. This includes the fact that the plant material itself may not clearly express the color reaction that takes place. Furthermore, a wide range of primary phenethylamines and amphetamines may yield similar color reactions. The presumptive tests which can be satisfactorily used is the Marquis test. A positive and a negative control test should also be carried out. An orange red color will develop if mescaline is present. However, due to the difficulties associated with the interpretation of such results, further confirmation of the presence of mescaline by using chromatographic and spectroscopic techniques is required. The TLC analysis is a rapid technique which can be used to determine whether the mescaline might be present in a sample. An extract is prepared from the plant material by powdering the latter and then repeatedly extracting this into a mixture of methanol and ammonia. The lipids are then removed by extracting into diethyl ether and using the methanol layer following the phase separation. The chromatographic plate is spotted with the extracts along with the positive and negative control, and a number of different solvent systems can be employed for this purpose. For example, the mixture of ammonia and methanol, mixture of chloroform and methanol, and mixture of chloroform and methanol and ammonia can be used, in which gives the RF value of mescaline as 0.20, 0.10 and 0.36 respectively. The chromatographic plates following development is removed from the TLC tank. The solvent front is marked with the chromatogram, air dried, and then visualized under UV light after spraying with the ninhydrin or fluorosamine reagent. If ninhydrin is used, the chromatographic plate should be heated at 120 degrees Celsius for at least 15 minutes to visualize the mescaline. And if the fluorosamine is used, the plate should be sprayed and heated with the hot air blower. The developed spots should be observed under the UV light, where the product formed with the mescaline will yield a bright yellow spot, which can be intensified on exposure to the ammonia vapor. Following the TLC analysis, the mescaline can be analyzed by HPLC also. The mescaline can be analyzed by using a number of HPLC methodologies. Most of these involve reversed phase system based upon ion pairing type separations. In the first of these systems, the dried plant material was powdered and then repeatedly extracted in methanol. The lipids were removed by extracting into the diethyl ether, and after phase separation, the methanol extract or the methanol layer can be used for chromatographic analysis by using the specifications given in the table. The column which is used is of ODS silica of the length 15 centimeter and 4.6 millimeter inner diameter with 3 micrometer particle size. The mobile phase used is a mixture of water, acetonitrile, orthophosphoric acid, and hexylamine. The flow rate maintained at 1 ml per minute, and the injection volume is 5 microliter. The detector is a UV detector. Similarly, the GCMS analysis can also be used to analyze the mescaline sample. The dried powder material was soaked in the chloroform for 20 minutes, and then the mixture is centrifuged and the supernatant recovered and evaporated to the dryness. The material was reconstituted in 0.5 ml of methanol and then subjected directly to GCMS analysis using the following operating conditions. By employing this analytical process, it is possible to determine the presence of mescaline in the casework sample without any difficulties, and the results can be easily compared with the standard.